I won't be short, I'm sorry. Not shorter than Misha. So my name is Katerina, or Kate, and I'm working in Itera as a QA coordinator and security testing specialist. And I work in Itera for 7 years now. And 3 years ago, when we started developing the security testing or service, build the competence in Itera, I was participating in this activity. And since then, I was fascinated with security, and now that is my passion, I would say. And since then, we had completed several internal and external projects on security testing only, and as part of other services we do in Itera. So, today I would like to tell you briefly about what security testing is, about main vulnerabilities we verify in security testing, and if you want to start security testing in your project, how you can do it. And for those who is interested in this area, I will suggest some materials, tools, practice that you can do and become a true hacker after that. So, what is security testing? Internet provides us with enormous amount of information and services. Everything starting from social networks to building a business online. But of course, it's not a secret that Internet has a number of serious problems. Problems related to security and to data confidentiality in most. I would like to start my talk with an interesting example, I would say. So this attack was called probably the largest attack in 2015, the attack to USA government. During this attack, there were stolen about 22 million records of USA citizens, but not just usual citizens. It was the information about the government employees, judges, secret agents, military people working in the USA. So, hackers got access to all their personal information, including social security numbers, including email addresses, accounts, including their residence addresses. And some of the records even contained fingerprints of some people. So, the hackers actually did the attack in 2 stages. Firstly, in April 2015, they stole about 5 million records from the database. It wasn't just one database where all the information was stored, of course, but they managed to get access to this storage and copied about 5 million records. After that, the USA government hired the independent consultant who did the forensic investigation and provide recommendation how to close this breach, and charged the government for $135 million for his consultancy. And after that, 3 months later, there was another breach. And 17 million records more were stolen. The information, of course, there are no official, not commands, but official information how they got access to the storage. But the rumors said that they used the compromised account of one of the vendors of the USA government services. So the potential loss of this attack is hard to calculate, of course. There are no direct money that were stolen, or the business was not interrupted. But the experts claim that the USA will pay off for this attack for several years, because the social security numbers is the most important information the USA person has, the American has. Because if stolen, it can be used for impersonation of this person, for stealing his life, I would say. And of course, we need to remember that the information contains some like some records about the people participating in military operations, the secret agents participating in some operations, the people who were participants of witness protection programs. All this information was in the hackers' hands, and we don't know how they will process it further. So this example shows us that security should be in top priority for systems containing personal user information or information that can be interesting for the hackers. Security is a very wide area. Unfortunately, you cannot say that your application is secure just by performing penetration testing. You need to have a complex approach. You need to make sure that the infrastructure where the application is hosted is secured, as well as making sure that the end users follow simple security rules. In big organizations, the first dimension is usually left to IT departments. These guys implement the security policies. They track the network for suspicious traffic or some potential denial of service attacks. They are making sure that the service and the databases are properly protected, there are no open ports and all this stuff. The third dimension is usually implemented by a special security officer. This guy is implementing the information security strategies. So he's making sure that all the vendors are signed the NDAs, that there are no production data on the test environments, and all this other stuff. And of course, if the company is certified for security standard, this guy is the one who is implemented and controlling it. And the second dimension, application security, is usually left for project teams. And sometimes the project teams don't have proper skills or knowledge to perform security on an appropriate level, to guarantee that the application is secured for their users and they don't need to be worried about their personal data stored there. And usually security is something that is forgotten, and the people remember about it just before release and say, oh yeah, we need to test security. And then the situation like this can occur, and then you need to spend a month for security testing. Then you find some critical errors, and then you need to redevelop your application. You need to change the architecture sometimes. Sometimes the errors are easy to fix, but sometimes you need to redesign the whole application. And what applications need security testing? Of course. Have any one of you heard about the hack of Sony PlayStation network? Yes, some of you did. Have you participated in it? Okay. For those of you who haven't heard about it, in 2011 or 12, I don't remember correctly, the Sony PlayStation game network was hacked, and the hackers stole about 77, I think, million accounts of the users of Sony PlayStation. So they stole the security not security numbers, but email addresses and account information, passwords, and some billing information, because there were credit cards that were attached to the accounts. And they prevented the users from playing online for about a month for some of them. So the network was closed, and there were some losses, of course, business losses, because the business was interrupted. So what I mean here is if your application contains personal user information, critical user information, or if your application is the core of your business, it makes your money, then you need to test the security. Of course, it's not critical for applications. For example, you have an internal website where 15 of your employees publish their company news. Well, that's probably not the most critical application to test for security. And also another point I would like to pay your attention to is that your application may be secured enough, but you may integrate with the application that is not properly secured. And the vulnerabilities can occur on the integration layer when the two applications communicate with each other. And you think that this is, for example, the responsibility of another vendor to test it, and the vendor thinks that it's your responsibility to test it, and that's why nobody tests it. So you need to remember about it when planning your security testing and analyzing the scope for the work. And now I'd like to go briefly through the main vulnerabilities or threats we have in security testing. This is the OWASP top 10 list of vulnerabilities. OWASP is the largest security community in the world. It's a free community where people dedicate their time and efforts to actually they have different activities from gaining some statistics and analysis to developing free tools for security testing. And once per 3 or 4 years, they produce this list of top 10 most important vulnerabilities, most common vulnerabilities. And this one, the last one was produced in 2013, so I expect this year they may include something else. So this is the analysis of about 500,000 vulnerabilities in thousands of applications. So the data is well, pretty relevant, I would say. And I would like to stop on 5 most exploitable of them. So the one that are most easy to find. First one, and number 1 on our list, is injections, of course. So injections is the failure of your application to properly validate the input from end user or other application services. If succeed, injections can lead to data leakage from the database or from web services. And the hackers can implement the injections almost in any type of application, so either web, desktop, mobile, or cloud. Injections can be of different types. The most common is probably SQL injections. This is the injections of the in the database. And the countermeasures here is, of course, sanitizing user input. So you can use different techniques like validating the input on the client side, on the server side, creating blacklists, whitelists, and other stuff. But the user input should be sanitized as much as possible to prevent the injections to the application. And another example. Probably the most sensational injection of 2012. The leakage of LinkedIn passwords to the network. I think most of you got this message in the LinkedIn that you should change your password several years ago. It was blinking all the time you logged into the system. So what happened? The database of about 7 million accounts leaked to the internet. And the hackers were able to steal this database and then to dehash the passwords. So the passwords were in the internet were published in open format, not in a hash. I remember reading something that a LinkedIn Facebook plugin was used as an entry point there. And actually the reason why the passwords were dehashed was because they were not stored properly. The hash function was not used properly, so the hackers were able to dehash it with standard technique, like rainbow tables, I think. And yeah, it led to, well, of course, there were some financial losses, reputational losses, and actually people need to change their passwords, and LinkedIn need to make sure they do it. Yeah, maybe questions we have so far. You can ask questions in the middle of the presentation, because it probably will be... Oh, anyway. Rainbow tables is the technique that is used to dehash the passwords when you have, for example, MD5 hash. It's a technique and the tool that is built upfront this technique that is used to actually get the open passwords from it. Yeah, the next vulnerability, not vulnerability, but probably threat we'll have is sessions. So session attacks are attacks when the attacker is able to fully impersonate the victim in the application. So I think you know that sessions are tracked using a special unique identifier that is passed from request to request, and all the requests with this identifier belong to one session. And the goal of the session attack is actually to steal this unique identifier. It can be done in different ways, from sniffing traffic between user and server, or using some social engineering techniques, for example. And if stolen, this session identifier is stolen, then the hacker can do in the session everything the victim could do. That's why usually the highly privileged accounts, like top managers or administrators, are targeted. The session attacks differ by the way they exploit the breaches, the vulnerabilities. When we are talking about the sessions, the separate attention should be paid to people. Because, as I mentioned, the social engineering is usually used to get this unique identifier when the link is sent to the user, and the message is something like, "Oh, you should open this link. It's very cute picture of a dog or a cat or something else." You follow this link. You follow to some website that contains a script that steals your unique identifier. And after that, the hacker can log in the application with your identifier. Not log in, but use it to get access to your session. Session attacks are mostly used in web and cloud applications, and mobile, of course. In desktop, they are also possible, but it's much harder to exploit them in desktop applications. And I'd like to show some video. This is the example I found on one of the public sites. The site is named hrs.com. This is the service like Booking. They provide you the service of booking the hotels. So you can find the hotel, book it, pay it for it, and manage your booking, something like this. So what we have here, this is the main page. We have a login window here. I log in, I'm an attacker now, and I log in with my credentials. This is like personal details information that we will check. And here we see that, we have our unique session identifier that is stored in the URL of the browser. It is usually assigned to a session after we log in to the application. What we do next? We log out from it, and now we see that the session identifier wasn't deleted. So it's still there, it's still in the URL of the browser. And what we do? We copy this link and send it to a victim. As I said, you can do it in different ways, open this link and see that there are some promo on this website, you need to check it, something like this. So the victim follows the link. He or she opens it in the browser. And now he or she, anything happens? Yeah. So he opens the link, and we see that the session identifier is still there. And now the victim logins to the application. He enters his own login and password. And we see that identifier hasn't changed. It's still the same. So now it was just reassigned to another user. What we do next? The victim serves the application, opens some pages, do some actions. And now we are again an attacker. And what we do? We need just to refresh the page. Because the session identifier is still the same. Now we are working under the victim session. Yeah, so we see the personal details of the victim here. Oops. So this attack is possible because of the session management mechanism. So the developers were not updating the session identifier each time the new user or the same user relogins. That's why we were able to reuse it, the same session identifier over and over again. After I found this vulnerability, I wrote to this company, hrs.com. I wrote them a letter saying, okay, guys, you have this, you need to do this, this, and this, and then you can steal almost any session. They haven't replied to me. Yeah, but I checked, I think in a month, I checked it again and it was closed. So now, even if you want to, you can't make profit from this vulnerability. Yeah. Another type of attack, mostly, I'd like to talk to is cross-site scripting. So the cross-site scripting is another injection, but it's separated in a group, in a separate group, because it's very, very common in most applications. So cross-site scripting is an injection of JavaScript code into the trusted application. So the attacker, again, he or she could send the link to the untrusted website to a victim user. The end user browser has no way to know that the site shouldn't be trusted, so the link is opened and then the JavaScript code is executed. The browser executes this JavaScript code. And after the code is executed, it can access any cookies, any information that is stored into the browser related to this website. The cross-site scripting attacks are most common in web and cloud applications because it's browser-side scripts. So the desktop applications are not vulnerable to it. And as well as native mobile apps, because they have some prevention mechanisms. And one more example. Twitter. Yeah, Twitter. Several years ago, there was discovered an XSS attack in Twitter client TweetDeck. The attack left several millions of user accounts opened to hijacking. So what happened? It was actually discovered by a teenager who was experimenting with this hard Unicode character. And during this experimentation, he found out that anything in the message that is ended with this hard character is treated as an HTML code in the TweetDeck. So I don't know, was it a feature or a bug? Yeah, but probably they were supposed to use it to format the tweets, like changing colors and fonts. But I think 2 hours passed before the first worm was developed for this vulnerability. And the worm, it has a script that when you are reading the tweets on your application, when you come to this tweet, the script is executed and the tweet retweets itself. So without you actually knowing it. And by the time the Twitter closed the application, there was about 82,000 retweets of this message, so it was spreading itself into the network. And I think the Twitter actually coped with it pretty quickly, several hours, and they were opened again. They just deleted this message from everywhere and fixed this vulnerability. So also very interesting example. The next one is misconfiguration of your infrastructure. So the first dimension that I was talking previously related to this. Separate attention should be paid here because if your infrastructure is not secured enough, if there are some open ports or easy access to the server, web server, the hacker can steal all your content or modify it slowly over time without even logging into the application. The misconfiguration can happen on any level of the application stack. It can be operating system, it can be web server, it can be database, some frameworks or custom code that you use. It all can be the input vector for the hacker. And the most common examples are when we deploy the application to production server and we forget to change the default passwords on a database. Or like directory listing, it's the display of all the folders and files you have on a web server in a browser. So this should be forbidden, and sometimes the administrators or developers who deploy forget about it, and the hacker can browse the whole structure of your application, download any files, get access to any information. This may sound pretty obvious, and you may think, okay, I'm not one of these guys. But sometimes when we are in a rush before release, when we are in a rush with hotfix, we can forget about it, about the simple security rules. The last one, it's not a vulnerability, it's more like attack, denial of service. I think everybody of you heard about it. So the denial of service is an attack when the hacker makes the target application unavailable for the end users. So the user cannot open the website, he cannot do any actions with the applications as he was supposed to. And the denial of service can be divided on 3 levels. So the bottom one is network level. In this case, not we, but the hackers, try to exceed the maximum bandwidth of the network channel. So they use one channel and they send as many requests as possible. So the users who use the same network channel, they won't be able to send their requests to the server. The second level is the server level, and in this case, the hackers try to put down the web server. So they send as many requests as possible, as large requests as possible, so that the server will not cope with it. Usually this type of like attacks are handled with load balancers, different like separation of the servers, clusters, and all other stuff. And the last one and most, I would say, interesting one is the application level. At this level, the hackers analyze the logic of the application, analyze the architecture of the application, and try to figure out the situation when, for example, the huge request is sent to the application. Your application uses a database. When you use search, for example, you put some search word, click search button, and the results are displayed. For example, the hacker wants to display all the results, all the database in this request. So this will be one very huge request that will be processed very long time, if processed at all. And in this case, the users who are working with the same database at the same time, they won't be able to get any information because the database is overloaded. It processes this one request. The application level can, like the application level vulnerabilities can happen in any types of the systems. Of course, it's more time-consuming to find these vulnerabilities, but they are more expensive to fix, but they are more dangerous, I would say. And the server and network level vulnerabilities can happen only in distributed application. When you have a network connection, when you have client and server that communicates with some requests. So these are the targets for these types of vulnerabilities. So, before we proceed, any questions, comments? You would like to share your stories? Okay. So, how you can start doing security testing on your project? First of all, the projects can be divided into two types. So, standalone security testing or built-in security testing. The standalone projects are projects when the system is almost finished. So you have the overall working system or some component of the system, and you do penetration testing on it. So you don't prevent any defects. You just verify what you have and try to find the security flaws in it. In this approach, the good part is that you don't need to spend a lot of time on security. The bad part is that if something critical is found that requires changes in the architecture, then you can be delayed with your application because you need to redesign and redevelop it. And the second approach, it provides, not provides, but its goal is to prevent the defects from the very beginning. In this case, the security specialist is working from the very beginning, from the requirements stage, and participates on every stage of the development life cycle. Yeah, standalone security testing. These are like the main phases we have in the security testing process. It is built based on OWASP approach that they recommend. So first of all, we have initiation. Of course, we just discuss with development team or test team or whoever we have. Our scope, our targets, what we need to test, what we need to pay our attention to, how the application is used, and all other stuff. The next stage is information gathering. It's the stage where we try to get as much information as possible about the application. So we analyze the business scenarios. We analyze the architecture. We can analyze the code even. We try to get the usual workflows in the system, how the users work with it, and other stuff. After getting all this information, we design some sort of checklist, for example, or scenarios that we will verify further. At the testing stage, it's pretty clear. We do testing. We do verifications. We can use special tools for security automation. I will give the list later. And after performing all of the tests, we do risk analysis. Risk analysis, I would say, is the most important phase because, for example, imagine we found 10 defects, security defects. Each of them separately won't present any danger to the customer, to the application itself. But if combined, they can lead to possible exploit scenario. In this case, we need to analyze not defect one by one, but we need to analyze their set. And we usually combine defects in some risks. For example, these defects will lead to this risk, and these defects will lead to this risk. And we evaluate the risks to the application. I will also show some examples later. And reporting, presenting the nice and clear report to the customer. And the last one is regression testing. So if it's the repetitive activity, you may do regression testing of the defects that were found and then fixed by the developers, and you need to retest the defects and probably do some regression testing of the application itself. I mean, from the security point of view. And if we have the second approach, the built-in security testing, then we see that we have security activities on each stage of the life cycle. So during the requirements, the security specialist can work together with business analyst on requirements and suggest some best approaches to authentication, to, I don't know, session management and other stuff. Of course, these are not the parts of business requirement specification, but they are the parts of software requirement specification. At system design, the security specialist can do threat modeling, for example. This is the practice when we analyze the input vectors and data flows in the applications, not further, but future application. And we try to think what vulnerabilities can occur there. So we try to prevent them, and we try to think how the hackers may misuse these flows. During the system design, this practice is very helpful to prevent the defect, security flaws. During the development and testing, we usually do penetration testing or some analysis of the code, scanners, scanning the code and other stuff. During the deployment, the security specialist can verify the infrastructure, so to prevent this misconfiguration I was talking about. And at maintenance, we just continually monitor that the application security. If some incidents happen, we monitor why they happen, what should be done, how it should be fixed, probably do some retesting and other stuff. And if you use Scrum, these phases are just continuing. Risk evaluation. As I told you, this is the most important phase, probably, of security testing. Oh. Yeah, you saw this, yeah? Risk evaluation, yes. This is the approach that also OWASP recommends. So we analyze the risk, as we usually do, from the terms of impact and likelihood. But we have another set of factors we analyze in security. So the likelihood includes 8 criteria divided into 2 groups, so threat agent and vulnerability factors. So what is the likelihood that this vulnerability will be found by the hacker? And the impact, it's actually the impact to the application. The impact is divided into technical and business. And in our practice, we usually evaluate one of them, not both of them. Business impact is very hard to define for like security specialists, for developers, for testers. So if you are working together with customer on this, then the customer will be the best person to define the business impact. So how the business will suffer from this vulnerability if it happens. And the technical impact is more like the technical stuff, how fast it should be fixed, what are the interruptions, do we have some data integrations problems and other stuff. And the risk evaluation metrics may look like this. So we have a list of risks. Each risk has a number of defects we found in the system, and then we evaluate the risk and calculate the overall one, like high, medium, or low. So all this approach is described in the OWASP, so you can read it carefully if you want to. And a couple words about test automation. So Misha already told you about best practices in test automation, and security test automation is not an exception. We, of course, can automate some repetitive tasks, and the test automation approaches or groups of tests can be divided into 3 levels. So the first one is when we do automate the scanning itself. So for example, imagine you need to verify the application for injections. The application contains I don't know, 20 fields, and each field can include different data. And you have like a vocabulary of XSS injections, like the code itself, encoded, decoded, different tags and other stuff. And you need to verify all the 20 fields. So to do it manually will be a waste of time, really. And there exist some tools that help to automate this process. The scanners, they are called the scanners or scanning tools. The examples are listed on the slide. For example, for application scanning automation, you can use Burp Suite, that's the commercial tool, or Ovechenko, that's the free tool. So you just give a link, provide into the tool a link, say what fields you need to verify, and open the the scanner itself. So the tool will send the request from vocabulary one after another and provide you the report after he finishes. The Nessus scanner is the infrastructure scanner. So if you need to scan the IP addresses and open ports and see what services are running on these ports, you can use the Nessus in this case. The second group is tools that can help you to do automation to check the common weaknesses into the application. So these weaknesses are usually verified manually, like absence of HTTP-only flag on a cookie, or user of some weak SSL cipher, or stuff like this. These tools or frameworks, there were created several frameworks that combine different exploits. So you run the framework, and also like in the first case, it applies one exploit after another to verify for common weaknesses the application. But still, in both cases, you need to first do some manual job. You need to understand what types of attack can happen in this and in this application, in this and in this case. And after that, use the tools. In my practice, I usually use several tools and then compare the results, because unfortunately, you cannot trust one tool. And the third level is just usual functional test automation. There are some vulnerabilities that can be found only manually. For example, if you have some untypical authentication mechanism or session management mechanism, if you need to test for access control, if you need to test for authentication, how the user can, for example, exceed their rights in the application. All these scenarios first need to be run manually. You need to understand how to misuse the function that you have, functionality that you have. And only after that, you can write this scenario and automate it using usual test automation tools like Selenium WebDriver or any other. Yeah. So the tools. What I recommend to use if you are doing security testing or want to start doing security testing. For testing the sessions, of course, you will need to identify look through the cookies you have in your browser, and there are special plugins you can install and play with the cookies, like edit it, delete it, put or delete some flags on them, and other stuff. For the web applications, cloud applications, of course, you need to analyze the requests that are sent from server to client and back and forth. For this, you can use different interceptors. For example, Fiddler is the most commonly used. However, there are special tools for security that provide some additional functionality, like Ovechenko, I've already mentioned, Burp, and other stuff. These three help to intercept only the requests that are coming from your computer to your application. So you configure your browser, and then you see all the requests in this tool. These ones can catch all the traffic that goes into the network. So, for example, you can see the requests that are sent by your colleague to the server. So Wireshark, for example, can be used for this. And if you try to install Wireshark, your antivirus will scream and say, okay, virus is detected. Scanners. So the scanners that were mentioned here are like Aconetics. It's a powerful scanner that can be used to scan for different types of injections, for working with web services and other stuff. OWASP Burp Suite provides the same functionality. Metasploit is, I think it's commercial framework. Also the same functionality, but since it's commercial, they put a lot of efforts to maintain it, and it has much more, how to say, the vocabulary of the injections they try, it's much wider in the Metasploit. Configuration, analysis of the infrastructure, there are several tools to use. Web services testing. Now, at my current project, I use SOAP UI. I'm not a fan of SOAP UI, but unfortunately, this is the only tool that helps to do more or less comfortable security testing in my project. And it has a separate module called security. And when you connect all the services into the SOAP UI, you can then run this security module on all the services. It will verify for basic injections, mostly. Probably the most important here is, it's on the bottom, I'm sorry for that, Kali Linux. Kali Linux is a penetration testing platform that you can download for free, and it has tons of tools and scripts and exploits installed already into it. And you can test, I don't know, probably anything with Kali Linux. The only problem for some of us is that most of tools don't have user interface, so you need to run them from command line from Linux. And this is something, if you don't know Linux, you need to learn then. But that's a very, very powerful platform. And some recommendations, next steps. So if you are interested in the topic, you can read several books. Personally, I suggest to start from OWASP Testing Guide. It's also free, and it provides great structural information about all types of vulnerabilities, how to test them, how to find them, what tools to use, what are the countermeasures for each of it, and other stuff. It's, well, it's large, really large, but you can pick the topic you want and not read the whole book at once. Some internet resources, some communities, some checklists that are published online. And if you already read some books and you want to practice, there are also some applications with vulnerabilities built into them, so you can deploy it on your computer and practice. Also, OWASP provides great applications. Yeah, and certificates for those who are interested. ISTQB recently, not recently, but several months ago, announced the security testing certificate. So, also a couple words about the practice. If you want to practice on real projects, like not to do some studying hacking, but to practice on a real project, there is a legal way to do it, and it's called bug bounty programs. Bug bounty programs are the programs announced by big companies when they pay users for finding vulnerabilities. All big companies like Google, Facebook, Yahoo, everyone, I think, have these programs. And here are listed the platforms that combine several programs from different companies. You can register there and, connect into the program, participate in it, and find some vulnerabilities and get some money. For example, Uber pays $3,000 for the XSS found on the main page, and $2,000 for the XSS found on subdomains. So you can make easy money from it. There are some, I would say, more or less easy programs. Some of them are more advanced, like finding vulnerabilities in embedded software or something like this. Tesla, for example, has bug bounty program. The only problem is you need to have Tesla to participate in it. I would really recommend to, if you're very interested and you have some knowledge already, I would really recommend to participate here because you will get the real hands-on experience in security. And at the end, I would like to say that there are no secure applications. Some of them just haven't been hacked yet. That's all. Thank you. Any questions?
I have one. Can you tell you are being hacked? Or have you been in that situation with the application you were working with? You actually are aware of people trying to get in?
Of the application I tested or I worked with?
Both.
Both?
Like from movies? Like from movies?
Yeah, hacker battle.
From the applications I've tested, I haven't heard that they were hacked after that. It doesn't mean I'm a really good tester. It just means that probably the applications were not very interesting for the hackers. I don't know. For the applications I've worked with, I can't remember. I know that recently I was tried, not the hackers, but someone was trying to trick me using the social engineering. I got a call from my bank saying that I got a money transfer from another account and I need to approve it to get it. And they tell the name of a real person, my friend. And after that, I said, what do I need to do? Okay, you need to put your credit card into the ATM and then I would say you what buttons to push. I said, okay, but what I need to do? Your money are now stored on some mobile account or some virtual account, and to get them you need to do some actions in the ATM. I said, okay. When you will be, I said, what I need to do? You need to enter the amount and you need to enter there some transfer code, something like this. I was wondering where I can get this transfer code, and I was told that, okay, you get to the ATM, you enter, insert your card, and then we call you and say this transfer code because it's valid only for 10 minutes or something like this. Okay. And then he said the phrase that actually, after that I thought that that's not my bank. Because there are several banks, of course, in Ukraine, and two of them are state. And he said, your transfer is from the second state bank, and we are working together. So can you tell me how much money are on your account? I said, why do you need this information? Well, after you get the money, we will verify whether you got it or not. I said, what? Yeah, so it was a very long phone call, but afterwards I said, no guys, I won't do what you asked me to do. And they dropped the call, and when I tried to call this number again, it was already blocked, so yeah, not my bank, I think. Yes?
Based on your experience, From what size of the project must be interesting in the security test? So how big must be the project, or how complicated must be the software which is developed that we need to use this security test? Because obviously some, I don't know, maybe some easy or easy software or some small projects will not spend money for that.
Well, you know, the size of the project, the amount of people working on the project, it doesn't matter. Because you can have a very easy online shop with several pages and CMS under it where you configure the goods, so whatever you sell. But you will have this information, like the billing information of the customers. Customer will enter some credit card numbers and other stuff. And you need to do security testing. It all depends on what information is stored in your application. Is it private information? Will your end customers suffer if this information will be stolen? Will there be any reputational risks? For example, like in LinkedIn, there are no billing information stored there. But there are some reputational risks because there are millions of people using it. And they will just switch to another network. After 2 or 3 times, they will be hacked. So really, it doesn't matter whether your application has 1 page or several hundreds of screens. All is about the information that is stored. Yes?
What is your point of view on the recent ransomware attack?
Ransomware?
Yeah, ransomware.
You have any particular examples or just...
Friday.
Hospitals, German station displays and so on.
This Friday?
Yeah.
I haven't heard about it, sorry.
What? So it was across Europe.
So it worked, yeah.
You were down.
Yeah, there are no ransomware attacking here, so... Yeah, but I haven't heard about it, but the common, like...
I think it's the most common type of attack in the recent.
Yeah, when the virus is blocking your screen and... Oh, no, you know, I remembered.
Yeah, and that's the best thing. It
Yeah,
came through Windows
because-
updates.
Windows is bad.
Yeah, I remember I was coming to start some state service on last Saturday, and they said that, sorry, we are closed because we catch some virus on Friday. And they're still closed, actually. Yeah. Yeah, I would say that's pretty common now. And what's your question about the ransomware?
What is the most effective defense against ransomware?
Don't open links from untrusted sources.
Okay.
Yeah.
Well, Windows was trusted. It came through Windows.
But it was not updated, so problem was in the infrastructure side. Patch was released in March, so if you didn't manage to patch the systems in 2 months, or you have already old system on Windows XP, you should just
Yeah, unfortunately,
shouldn't have done.
for example, in this case, if it came from Windows, you can't protect yourself from this. There are some executable files that run on your computer and install this program. In other cases, you can just prevent installation. There are various ways. It's just simple security rules again. Don't, if you found a flash drive, don't take it into your computer. That's simple. Don't open some links. Don't install some strange software. Something like this. But from Windows, or like the Heartbleed attack, yeah, nobody expects it. It just happens, and you need to do something with it. Yeah.
I wanted to say with this attack, the problem was it was not some executable. It was from one computer. If the second system was not patched and it was in the same network, it just jumped to another one. So no user interaction was needed. If the system wasn't patched, and the network infrastructure wasn't isolated good enough. Because this is one of the principles that we try to isolate the system. This is the reason.
Yeah,
It's well done, actually. It was
Probably.
very well done. But yeah, I didn't see that.
any other questions? Okay then, thank you.